Hi there, this is MJ on the journey back to Silicon Valley. Today we're going to look at problem 242 on Leetcode, valid anagram. So, given two strings S and T, return true if T is an anagram of S. Otherwise, return false. So, in the beginning of this problem, it wasn't clear to me from the description what an anagram actually is. So I started there. So basically I understood I can say that a word is an anagram of another if it contains the same letters in the same amount regardless of order. So my initial thinking was if both words have the same letters, if I sort them alphabetically and then compare them, I should get back the same word. So with this approach, I wrote the following steps. So first step, I will convert S and T into arrays. I will sort them alphabetically, and then I will compare S and T. If they are equal, I'll return true. Otherwise, I'll return false. So using the magic of JavaScript, built-in functions, split to turn strings into arrays, sort to sort them alphabetically, and toString to turn them back into, to turn arrays back into strings, I wrote the following solution. So as you can see here, we're initializing a variable S, and in that variable, we're taking the string S that's coming in from the arguments, we're splitting it, and then sorting, and then putting it back as a string. And we're doing the same thing for T. And then we're checking if they are equal, returning true, and if they're not, we'll return false. So this code did get accepted on Leetcode, and I submitted, and here are the stats. So the solution is beating only 66% of all submissions on Leetcode for runtime. And it's beating only 8% of submissions for memory. So I think on the memory side, things are pretty bad. But let's look at what's going on here. So the split function has a time complexity of ON, because it's dependent on the number of characters in the input string. The sort function, which is going to be called on the resultant arrays that we get from split. So the sorting it depends on the implementation, but by default, it has a complexity of nlog n, because it's using a TimeSort algorithm. And by the way, Chrome uses quicksort, and TimeSort or quicksort have a nlog n complexity. And then the toString has a O of n complexity, because it's dependent on all the numbers in the object. Now, mind you, maybe join is a better pick here, because toString is also for converting objects. Join is specifically for arrays. So the total complexity of the solution at worst is ON log n. And it did not look optimal to me. I actually didn't know it was optimal or not. I basically based it on it's only beating 66% of the submissions. But after a few Google searches, I decided to actually take another approach. The approach of counting the occurrences of characters versus sorting them alphabetically. So finding out what characters are there and then how many times they are occurring. So I discovered a hash map, which I can use a hash map. I can map each character to its occurrence count. And I can also take advantage of constant time lookup for hash maps, because hash maps have a constant lookup time when it comes to actually finding or looking up a value. So I revised my steps to implement hash maps actually, and these are the new steps. So the first thing is to check if the length of S and T is equal. This is a step that I did not include in solution 1.0, but it's a necessary step, because if S and T are not equal, there's no need for further operations. And the second step is I'm initializing an empty hash map to count the character occurrences in the string S. And I'm doing the same thing for T, creating an empty hash map to count the occurrences that are happening in string T that's coming in from the arguments. The next step is iterate through each character in S and T respectively. And then if I'm going to check if the character exists in the newly created hash map for S, for example. If it exists, then I'm going to increase its occurrence count. The mapping value, I'm going to increase it by 1. If it does not exist, I will add it to the hash map and then assign a 0 to its mapping value. And the next step will be to iterate through both hash maps that I've created and then compare values. If it returns false, so if the values are different in the newly created hash maps for S and T, then I'll return false. Otherwise, I'll return true. And this is solution 1.1 right here. So as you can see, we're checking if the length of S and T are equal, the strings that are coming in from the arguments. And then we're creating a hash map for S, a hash map for T to keep track of the character occurrences. And then we're stepping through the string S, through each character. If that character already exists in the hash map, if it doesn't exist in the hash map, we add it and then assign its mapping value to 0. If it doesn't exist, then we will increase its count by 1. And then after that's done, we're gonna iterate through the hash maps and then check if a character in hash map S is equal to a character in hash map T. If they are equal, if it goes through the whole thing, it checks it's equal, it returns true. Otherwise, if it finds that a character in hash map T is not equal to a character in hash map S, then we would know it is not an anagram. T is not an anagram of S, and we will return false. So I submitted this solution right here. It got accepted. And then it was a great improvement because it beat over 88% of submissions on Leetcode for runtime, and it beat 71% of submissions for memory complexity. Now, memory has really improved here. It went from 8% all the way to 71%. Let's go ahead and understand why memory has improved so much, and then resume back to try to optimize the solution or find another one. So after some research on Google, I found out that I understood why memory has improved so much. So solution 1.1 uses 2 objects, scount and tcount, to store the number of occurrences. Now, the size of these objects will depend on the size of the input strings. It's going to depend on the entire size of the input strings. In solution 1.0, O, however, which was the previous solution, the size of the input, no, I'm sorry, solution 1.1, the size of the input is going to depend on the unique characters in the hash maps. While solution 1.1, the size of the strings that we are creating will depend on the size of the input strings. So the reason solution 1.1 is better, because it only creates memory proportionate to the unique characters in the hash maps, while the previous solution creates memory proportionate to the entire size of the input strings. So that is why memory has improved so much. Now let's resume trying to optimize solution 1.1. It's beating 88% of submissions on Leetcode for runtime and 71% for memory, but we can definitely do better than that. So after some searches, I realized that I can only just use one hash map. I don't need to use both of them. So I can use one hash map to store the occurrences of S, and then I can iterate over string T to check if characters in string T are included in the hash map or not. So I revised my steps to do the following here. So first step, always, we check if the length of S and T are not equal. If they're not equal, we're going to return false, and we don't need to keep iterating. The second step, we're going to create an empty object, smap. And this object is going to keep track of the character occurrences in S. Then we're going to iterate through the string T to check if a character is already included in smap object. If it is included, then we would reduce its count by 1. If it is not included, then we will return false, because we're going to know that T is not an anagram of S, because if T contains a character that is not available in S, then it would not be an anagram. And then after all characters are checked, we're going to return true. So solution 1.2 looks like this. So we're checking the length of S and T. Then if they're not equal, we're returning false. And then we're creating an smap. And then iterating through S, checking if the smap object has the character, then if it has the character, I'm kind of blanking out here. Okay, so if it has the character, we will return. If it has the character, we will return that character and then add 1 to it. So we will increase its occurrence count. If it's not included in the hash map, then we're just gonna map it to 0. And here you can see this is a JavaScript OR operator. So basically, whatever you see in the parentheses, it's gonna return either the value or 0, either or. So if it does exist, it will return 0. If it doesn't exist, it will return the character occurrence. In the second for loop, we're iterating through T to check if a character is included. If it is not included, then we'll return false, because we're going to automatically know that T is not an anagram of S. If it is included, then we're going to reduce its count by 1. And once we do this for all characters, then the function will return true. Now, this thing was pretty confusing to me. I actually did not understand why reduce the count by 1. And after researching it, like, and rereading the solution and like looking at other articles online, I understood that the idea basically is that if we encounter a count that we cannot reduce by 1, then which would only happen in the case of 0. So if a count is mapped to 0, that means it doesn't exist in the hash map. And if it doesn't exist in the hash map, then we know that we can just return false. And we don't have to keep iterating through the entire characters. And okay, so I submitted this solution, and here are the stats. So it's beating now over 98% of all submissions for runtime, and over 95% of submissions for memory. So the results have improved, I can say, drastically. We went from beating only 66% for runtime, remember? And now we're beating 98% of all submissions. And for memory, we went from beating only 8% of solutions to beating 95% of solutions on Leetcode. And yeah, by the way, the whole explanation of the thought process and these trade-offs is available on Medium as an article. So you can go ahead, and it's also available on my blog. You will find the links to both the blog and the Medium post, and also the source code in the description of the video. And yeah, at the end here, it's a reminder basically of, if you're wondering why reduce the occurrences by 1, if you're not, totally fine, but this is something I kind of struggled with, and I'm not sure 100% that that's the optimal explanation, reducing 1 in case we encounter a character that has a 0 value. Basically the key is the character and it's mapped into 0, then we will automatically know it's an anagram. I think that is the idea, but perhaps this is a pattern or a programming paradigm that we would see come up in future problems. I hope this was valuable, guys. Let me know in the comments if you have any questions, suggestions, or anything that you think I can improve or I've done wrong. Please feel free to let me know. And until next time, this is MJ on the journey back to Silicon Valley.